The James Webb telescope has just detected a sudden 250% increase in Betelgeuse's brightness. Betelgeuse, the red star situated at the shoulder of the Orion constellation, has been exhibiting some weird behavior, fueling anticipation for a once-in-a-lifetime spectacle. Some say the increase in brightness could be the star getting ready to go supernova. But when exactly is it going to happen? Experts speculate that it could be soon. Join us as we take a look into the depths of space and delve into the mysteries surrounding this celestial giant. After all, Betelgeuse is capable of reshaping our entire understanding of the universe. A massive increase in brightness. Even if you're not familiar with its name, you've likely gazed upon the magnificent Betelgeuse. A radiant reddish dot shines brightly at the shoulder of Orion, that well-known constellation. Right now, Betelgeuse is incredibly massive. In fact, if we were to put it at the heart of our own solar system, its outer surface would reach beyond Jupiter's orbit. To this day, this colossal and easily observable star continues to fascinate us. Unlike most stars, Betelgeuse changes before our eyes due to its relatively close proximity to our galaxy. Betelgeuse is classified as a semi-regular variable star, meaning its brightness fluctuates, sometimes dramatically, as it steadily moves toward an eventual grand collapse and supernova explosion. Although already quite conspicuous, Betelgeuse has become even more interesting in recent years due to unexpected fluctuations in its brightness that we still struggle to comprehend fully. Why is Betelgeuse shining so brightly and behaving so strangely, though? It's uncharted territory. But its recent behavior was caused by an event back in 2020. Betelgeuse went through a period known as the Great Dimming in 2019 and 2020, which we'll get to later. But because of it, the nearest red giant star to Earth is now pulsating at double its usual speed, illuminating the early evening sky in the southern hemisphere. This strange behavior of one of the brightest stars in the sky is providing scientists with unprecedented insight into the demise of stars as it rapidly transitions between its bright and dim states. In recent times, Betelgeuse has occasionally exhibited more than 50% increased brightness. However, on May 20th, 2023, Betelbot reported something strange. Betelbot is a Twitter account dedicated to tracking Betelgeuse using information from the American Association of Variable Star Observation. It tweeted a staggering 142% surge in brightness. And now, the most recent updates indicate a 150% increase in brightness. Astrophysicist Andrea Dupree from the Harvard-Smithsonian Center for Astrophysics notes that it currently ranks as the 7th brightest star in the night sky, climbing 3 places from its usual 10th position. Now, let's not expect a sudden explosion like a bomb going off. There could be signs or smaller eruptions preceding the grand finale. And remember, Betelgeuse isn't the only red supergiant in our galaxy. Others, like Eta Carinae, might burst into the sky before it does. Statistically speaking, our Milky Way should witness a supernova roughly every 50 years or so. Surprisingly, though, we haven't seen one occur in the last 400 years, although we have observed remnants of past explosions. So, statistically speaking, we're overdue for an extraordinary cosmic event. It's just a matter of time before the next star puts on its dazzling show for the universe to witness. It went dim in 2020. Betelgeuse has quite the history. It's a star that has been the focus of many astronomers and fans of astronomy. One big event in Betelgeuse's lifetime was known as the Great Dimming. In the autumn of 2019, something extraordinary happened to Betelgeuse. Instead of its usual pattern of brightening and fading, the star experienced a significant decrease in brightness. This event, known as the Great Dimming, caused Betelgeuse to dim by around 60% within a few months. The red supergiant star captured the attention of astronomers during late 2019 and early 2020 due to its unprecedented dimming. Fortunately, Betelgeuse's brightness returned to its normal level by April 2020. However, the reason behind its dimming still remained a puzzle. Initial attempts were made to understand this strange event, but the complete explanation would only come in the following year. Skywatchers can easily spot Betelgeuse from their backyards, providing a wealth of observations. However, to gain a closer and more detailed understanding of the star, its atmosphere, and the significant changes it undergoes, scientists rely on observatories like the Hubble. The dimming of Betelgeuse, which couldn't be fully explained at first, led to speculation that the star might be on the verge of exploding. This sudden decrease in brightness raised the possibility of Betelgeuse entering a pre-supernova phase, preceding its explosive death as a supernova. The idea of a potential explosion captured the curiosity of people worldwide, as Betelgeuse would be the closest supernova ever observed by humans. Unlike our Sun, Betelgeuse is a massive star with a much shorter lifespan. One thing we know for sure is that Betelgeuse will eventually go through a supernova. When that occurs, the star will change into either a neutron star or a black hole. The exact result will rely on how much material is left behind following the supernova. The ancient Greek astronomer Claudius Ptolemy is said to have described the color of Betelgeuse by using a specific word. This word was hypokyrros, which means pale yellow, light reddish red, or anything in between. This suggests that the star may not have had the reddish color it has now. Even the Aboriginal Australians had knowledge of Betelgeuse's bright and dim cycles long before Western astronomers. They may very well be the earliest recorded civilization to have observed these cycles. There are clear records from oral and indigenous cultures that demonstrate their understanding of variable stars. Research has uncovered Aboriginal traditions from South Australia that specifically mention the variability of 3 red giant stars: Betelgeuse, Aldebaran, and Antares. The Aboriginal Australians' oral traditions have been recorded since colonization. Turns out, they've been observing the stars for over 65,000 years, giving us a treasure trove of information about the history of astronomy. This challenges what we thought we knew about the history of astronomy and highlights the remarkable observational skills of Aboriginal Australians, which have often been overlooked. Their traditions encompass a wide range of celestial phenomena, including the yearly rising of stars, the passage of comets, solar and lunar eclipses, beautiful auroral displays, and even the impact of meteorites. In Aboriginal traditions, celestial objects with a reddish hue hold special significance. This includes red stars, lunar eclipses, and meteors. Perhaps this is one reason why these stars are considered so important. The ancient Greek philosopher Aristotle, around 350 BCE, believed that the stars were constant and unchanging. This view was held by Western science for almost 2,000 years. However, in 1596, German astronomer David Fabricius proved this notion wrong when he discovered that the star Mira, or Omicron Ceti in the constellation Cetus, actually varied in brightness over time. In 1603, another German astronomer named Johann Bayer assigned the Latin name Alpha Orionis to this star, indicating that it was the brightest star in the constellation Orion. Despite later discoveries that Rigel is actually the brightest star in Orion, the name Alpha Orionis still remains. In the 1830s, astronomer John Herschel made an intriguing observation while comparing the brightness of several stars. Over a span of 4 years, he noticed that Betelgeuse, located in Orion, would sometimes appear dimmer and other times brighter compared to other stars. This finding set the stage for the emergence of astrophysics as a specialized field focused on exploring the ever-changing characteristics of stars. Betelgeuse has since been classified as a semi-regular variable star and has a longer cycle of approximately 5 years, which is different from the standard 400-day cycle. Despite humanity gazing at this star for thousands of years, there is still a lot we don't know about Betelgeuse. It goes to show just how much we have yet to learn about the universe, and Betelgeuse is just one piece of the puzzle.